Now in 14.5 we move to the topic of how to command the Baxter joints. Baxter arms can actually be controlled in 4 different modes. The top 3 are position control, velocity control, and torque control. For now we will just be focusing on position control. We can publish commands and also switch modes by looking at the topic robot limb, right or left, joint command. All of this topic is of type Baxter core messages, joint command, and that message type looks like this. We have a code, an integer code for entering the kind of modality that we want. Position is 1, velocity is 2, torque is 3. That will be set equal to this mode number. And then we need an array of names, an array of commands. So these can be, the command can either be the position, the velocity, or the torque. We have a C++ example to command joints. It's part of the simple Baxter ARM controller package, and a file of the same name is going to help us do the trick. We could just open that right here. .cpp. The highlights of the code are included in the presentation. Number 1, we need to include the type of the message we want to use for publication. Number 2, we're going to create a publisher called joint command pubwrite, and this is going to be a global publisher that is going to be used by the function command postwrite. Then we create the message, also a global one, Baxter core messages, joint command, write command. So we take that message type and access the names element and need to push back strings that describe each of the joints for the right side of the Baxter arm. So that would be right shoulder 0, right shoulder 1, right elbow 0, right elbow 1, right wrist 0, 1, and 2. Then we can also set the command mode equal to 1, which is for position control. Values can be assigned by going to the command element and pushing back a particular value. Here we just see how we might set all angles to 0 through a for loop and then fulfill the information for our joint command message. In the code, we're going to look at this silly command method that is going to push other kind of joint angle values inside. So if I go here to silly, run my silly program, we have this function where we might set some random values to this qvector1 array, and then use this for loop to set some of those values or pass some of those values, pass that vector, to the command postwrite method. This command postwrite method then extracts the double value that the array of doubles that we have right here, and sets them equal to the correct index within command, and then calls publish on the global publisher object, moving the robot arm in this way. So we can test on the robot. Let's make sure we have enabled the robot. Rust run Baxter tools enable. And then Rust run simple Baxter ARM controller. And we'll see how that robot moved to these 2 points. Let's do that one more time. There is the motion again, even if we zoom out a little bit more. One of the things you might have noticed about this motion is that it's quite jerky as it moves to a couple of joint points. To deal with the jerky motion, we're going to make use of an action client server that implements joint interpolation, just like we did back in section 11.5 and 0.6, where we did the interpolation for robots with 2 degrees of freedom and 7 degrees of freedom. To this end, we're going to use a special package for Baxter called the Baxter Trajectory Streamer package. So this package is a simplified package that does joint interpolation right here. And in the package, we have a file called Baxter Trajectory Streamer.cpp that implements a library for general use. So in fact, this library is going to be used to implement servers for both the right arm and the left arm. Then these servers will be tested through a main client file called the Trajectory Action Client Prepost.cpp, which is using an action message type trajectory action as the interface. This is the trajectory streamer, sorry. So here we have the traj action. As a goal, we have the standard trajectory messages, joint trajectory type, and then for the result, we just have an integer as well as for the feedback. Here we can see the header file for this class. So just to access that and show it to you. And then for the source, we have our library, we have our right and left servers, and then our client. The server will be interpolating waypoints every at a rate of 50 Hertz, and this will give us some simplified interpolation motion. So we can run the code by making sure to start the Baxter, enabling the robot, starting the action server for both arms, and then calling the action client. This will move both arms in turn. So over here I've started or launched the robot. Over here we can do the enable part. Then I will open a few more terminals to run the action server. This is going to be for the right arm. And then we can run the client in this last window. Called Prepost. You can see that now for the first time we're moving both of the arms at the same time, and we eliminated the jerky motion significantly, getting a really nice motion on both arms.